So for today's session, we're going to start a new unit, which I've mentioned before, which is a relational database management, database, relational database system. Then we look into management system, DBMS. So let me get the presentation for this session. Okay, so by database management system, we need to have an initial overview or understand what is a database. So by database, we simply going to look into collection of related information regarding an entity. This collection of facts and figures, once the whole process together, they can now produce information. So as you can see, mostly data represent recommendable facts, and they help on producing information which is based on facts. So by having a database, we're now able to having multiple information and for instance, we can have multiple entities in our DBMS. So by DBMS, which stands for Database Management System, is a simple software that allows creation, definition, and manipulation of database. So what it actually does is a tool which is used mainly for operations of database management system, where we can retrieve, add, update, or even delete entities. So as we all know, there are several softwares which allows us to work on management system, such as MySQL, Oracle, system-based Microsoft Access, or even IBM database too. So as we can see, Oracle SQL is one of the best, most used database system. Oracle. So if we go into Oracle website, we can now look into what are the products, and we go into database service. And then let me search for online Oracle. So normally to use this online version, you need to sign up with an account. So you just have to create your own account, and then you can now start working with a database. So what you ask you is to fill in all your details. So you can now collect the information. Once you filled in all your details, you can now use a database management system. And the programming language which used for database management system is SQL, which stands for Structured Query Language. So if you're going to W3 School, you can now SQL. Oh yeah, there's a SQL tutorial. So by following these examples, we will now be able to manipulate data from existing database. So what normally happens is that we have Excel spreadsheets with loads of fields, such as, for example, name. If we're looking into maybe a school management system, we can have fields such as name, surname, age, email, date of birth, or even the courses they're studying. And then with our database management system, we'll be now able to select specific fields. For example, here, there is an example of customer. So I'm assuming this is an example within a store or a shop where you're going to select the field customer, and what SQL will do is going to pop out with the related field. So here there are a couple of examples of what SQL can do. SQL can execute queries against the database, can retrieve data from database, can insert records, update, delete, and create. So there are loads of functionality which comes by using this programming language. So coming back to our presentation, so I gave a quick introduction of what the example of popular database management system, which I recommend to use Oracle. Also, we have to look into some of the characteristics where real-world entity, such as modern database management systems, is more realistic and uses real-world entities to design its architecture. Also, there are relation-based tables where there allows entities and relation among them from tables. Also, there is a isolation of data and application, which the system is entirely different than its data. Also, we can see a couple of other aspects, such as less redundancy and consistency. And then, as I mentioned, there is query language, which is equipped with query language, which makes it more efficient and retrieve and manipulate data. And then there are multi-user and current access. Also, other overviews we have to look into administration side, where administrators maintain the database and are responsible for administrating the database. So they are responsible to look after the usage, it should be used, and they also create access profile for users and apply limitation to maintain isolation and force security. Also, you have to look into design and end user, whereby design are the group of people who actually work on designing the part of the database. And also there are end users, which are those that actually reap the benefit of having a database. This end user might be students, clients, or customers. So when it comes to types of database, we all know that there are various types, and we're going to look into 4 of them, which are hierarchical database, network, and relational, and object-oriented database. As we can already guess from the name, these are all type of models where with hierarchical is simply going to work with a root, and this root might have its own leaves. Then you pretty much look like a tree, like a hierarchical model, where as you can see from the definition, the data model in which the data is organized into a tree-like structure, and the data stored the record which is connected to one another through links, and the record is a collection of fields, which each field contains only one value. While when it comes to network database, it's simply where the model database, which allows multiple records to link to the same own field. So we basically created a network where all of them can communicate, and they all goes back to a single file. And the multiple linkage, which is information, allows the network database model to be really flexible, and the relationship that the information has in the network-based model is defined as many-to-many relationship. As we can see, there are different types of relationships, such as one-to-one, one-to-many, many-to-many, and in this case, with a network database, we're going to look into a many-to-many relationship. When it comes to a relational database, which is what we're going to put our focus on, is simply the collection of data items organized as sets of formally described tables from which data can be accessed or reassembled in many different ways without having to reorganize the database table. So once you start using Oracle database or MySQL database, and you'll be working with list. For example, you have to make some registration list or check into other informations. You then have a relational database where all these entities are going to be related to each other. And this is how we're going to handle the data, manipulate the data, and this will happen through tables. Also, we have object-oriented models, where an object database is a simple database management system which information is represented in the form of object, and they pretty much used for object-oriented programming. And also there are different forms of relational database which they are table-oriented. So as you can see, the previous one and object-oriented, they're pretty much based on the same structure, but they could have the only slightly difference is that object-oriented will be more focused for handling object created with programming language. And also, we have to look into data models, where we're going to define how our logical structure will be implemented for our database. So as I mentioned, there are fundamental entities, and these entities introduce abstraction in a database management system. So these entities are connected to each other, as I mentioned, and they all process processed and stored inside the system. So a EFD model it simply gives us the understanding of how these entities are connected to each other. And most of the time, what happens is we then going to create a diagram. So there are different tools which allows us to create these diagrams in order for us to understand how these are going to communicate to each other and how this should how the workflow should be carried out. So what we have to understand is that within these models, the entities are the attributes, while the relationship among them, and then the relationship is how these entities communicate to each other. So most of the time, the relationship, we can look at them in like the arrows that are connecting to each other. So also regarding these relational models, the most popular model is DBMS, and there are more specifications and other models. But this model is based on the first order predicate logical and defines the table as an array relation. So now we're going to look into schema, a data schema. So by data schema is simply the skeletal structure that represents the logical view of our entities within our database. It also defines how the data is organized and how the relation goes among the associated entities. So it also formulates all the constraints that have to be applied on the data. So when it comes to a schema, also defines its entities and the relationship among them. So when we look into a schema, we have our physical schema, where it defines where it can be into two types, where is physical schema and logical. So with the first one, this schema pertains the actual storage of data and its form of storage like files. So as you can see is an actual physical database, while the logical database schema is simply defining the logical constraints that need to be applied once the data is stored. So the logical one is how we should divide our entities and how we now go with the logic of handling our data. So as you can see, there are various levels of data abstraction, where we have the physical, internal level, logical, conceptual level, and then we concluding with external level. So looking into physical level, where is our operating system, this is where we have all the physical components, and the layer above is the 3 layers above are internal level and logical, where all our database management is going to happen. And we'll conclude with external, where is simply our user interface and our end user level. So I've already explained how these flows are used to. So now we're going to have a quick look into big data. So big data nowadays is a really emerging technology, because as we can see from the name, it explains everything. By big data, we understand that is a really large amount of data. So we now know that technology has improved a lot, and this happened really through social media. I would say that was the peak when all this amount of data has started to be processed. So before the creation of Facebook, Instagram, all these social media, the volume of data that was shared was relatively low, where data was normally sent by emails or very small amount of size of data. But with the invention of Facebook and this social media, this consume of data grew up exponentially. And nowadays we also have IoT devices and any type of technology which they collecting data and they used for machine learning. For example, these IoT devices, they all now generating a large number of data. So as you can see, even from the past, people used to have maybe one phone, but now there are one phone, two, you can have even three, I don't know. You can have tablet, you can have any type of devices such as Alexa or many other devices, and these are all generating a large amount of data every single day. So what happens is that now we need to find
Here is an answer translated from GetAbridge.net.
Now we have to find, I apologize for that, but I do have Alexa right next to me. What happens is now we have to store this large amount of data in all the different servers. So as you can see here, big data explained. These big data include huge volume, high velocity, and extensible variety of data. The data in it will be on a tree type. So it can be structured data, semi-structured and structured data. So once we look into this, it's more pretty much related to even machine learning, where the concept is pretty much the same. So with a big data management, it is the organization, administration, and governance of large volume of both structured and unstructured data, where the main goal is the management is to ensure the high volume of data quality and accessibility for any type of business intelligence and big data analytics application. So as you can see, corporation, government, and government agency and other organizations employ big data management strategies to help them contain with high growing pools of data. So as you can see, for example, big data applications are maybe banking and security. As you can see, online banking, as nowadays everyone has online banking on their smartphone, which can generate loads of data and transaction that happens during the day. So it's really important to keep a high level of security. That's why we're going to look at the security exchange communication, which is using big data to monitor financial market activity. And they are currently using network analytics and natural language processor to catch illegal trading activity in the financial market. Also, there are communication, media, and entertainment. and which they simply collect, analyze, and utilize customer insights in order for them to improve. And then there are healthcare providers, which in the healthcare sector has access of huge amount of data, but it has been plugged by failures by utilizing the data to curb the cost of rising healthcare by ineffective system that stifle fast on better healthcare benefits across the board. So these are three major sectors where there are loads amount of data that are being processed during the day. So it is really important to focus on have a really good implementation of big data. Also, there is education and manufacturing and natural resources. So even in the education sector and manufacturing sources, there are large amount of data that gets created. Also, we have looked into transaction processing, where I've made the example of e-banking. Now we can see the transaction process system, TPS. It is an information processing system for business transactions involving the collection, modification, and retrieval of all transaction data. So big data has a big relevant part on online transactions, and also on transaction operation and states. Then there are online analytics process servers, where it's based on the multi-dimensional data model, which allows managers and analytics to get insight of information through fast, consistent, and interactive access to information. Then there are data quality management, which is an administration type that incorporates the rule establishment, rule deployment policies, and responsibilities and process with regard to the acquisitions. Then we have to look into data integrity. So by data integrity is we simply protecting the quality of our data. And as we can see, for example, if we're looking into a life cycle, by data integrity means that from the starting point to the end point of our life cycle, our data is not going to be lost or fragmented. So we're not going to lose any sort of important thing from the data. And also you have to look into data security, which we all know that there are loads of cyber attacks and cybercrime that happens on a daily basis. Therefore, it's really important for organization to ensure that the data is securely and secure managed. So this is everything for today. Is there any question for me? Adrian, you can leave a message in the chat box if you have any question for me. Oh yeah, let me check your chat now. No question. Okay. Thank you very much, Adrian, for joining. So I will see you on Friday. Have a good day. Bye.